Hello everyone, welcome back to the live session. So, as you already know, today's live topic is stock analysis. Okay, let people join more. So, today we are going to perform analysis on the stocks. Okay, so we have a data set which provides us daily stock market. Okay, for um, indicators for major global indices across North America, Europe, and Asia. Okay, so that data set but basically provides uh, daily stock market indicators for across continents like North America, Europe, and Asia. Okay, and this data set is particularly designed for you can perform data analysis, machine learning, okay, forecasting, business intelligence projects. Okay, so you can form multiple works, multiple different types of uh, works on this particular data set, okay, which we are going to use today. So it is a very useful data set, okay, and it's best for training purpose. If you are trying to train yourself on data analysis, so this is best. Varalakshmi, hi sir, good evening. Good evening. uh, Hello. Now, um hello, Ninaji. See, this dataset, particularly as I have already said, contains daily stock market data for major global indices from January 2020 to December 2024. Okay, so I'll just write this particular thing about the data set that it has indices from uh, January 2020 to December 2024. It means, yes, yeah, it means that it contains the COVID era also. Okay, so it particularly contains the COVID era too. So we will perform a proper analysis, okay, where we'll see that how the stock market has affected at the during the COVID period, before the COVID period, and after COVID period. Okay, so we'll do a proper comparison also. Uh, Sir, please teach us full ML course. Yes, yes, absolutely. I'm doing that. I'm up to that. Okay. We are preparing a playlist based on that. Okay. That's why I always come up with the latest tech. In the last live session only, I came up with the MongoDB. Okay. Because that is also one kind of database that is used in such things. Okay. And in upcoming, I'm planning many things in onto this channel. Okay, I'm planning to come up with big projects which uh, which are actually little complex projects where you can just use Flask, MongoDB, data cleaning, visualization, ML, everything that will means everything will required in that. So just stay tuned up, stay focused, join with our channel, okay, and you will be up to the mark, okay. So yeah, we are focusing on that, okay, Varalakshmi. So yeah, so this particular data set contains COVID era also, okay. Now let me just give you uh, it covers approx 10 indexes, okay, like uh, S&P 500, Dow Jones, FTSE 100, Nikkei 225, Hang Seng, okay, across North America, Asia, okay. So across this Europe, all these indexes it covers, okay. And particularly about our data set, The columns which we have in our data set is one, the date. Okay, date basically. Okay, let me write columns in our data set is actually like first of all is date, which is actually the trading date. Then there is index name, that is basically the name of the stock market index. Okay, and then there is the country, the country where the index operates. Okay, then country. After country, we have open. Yeah, open is one of the columns that we have. Open means here the opening price for the index. Okay, then we have high, which is the highest price. Then there is low, which is obviously the lowest price during the day. Then close. Uh, okay, screen is blur, I guess. I don't know. Wait, let me zoom it more. Uh, okay, Nedaji, I've just zoom little bit on my screen. Okay, so now I hope it will be clear. Okay, so please check, guys. Okay, and then let me know in the chat that if screen is clear or not. Okay, yeah. Then we have close, which is the closing price of the index. Um, then the next column is approx. Nine columns are there in this particular column. Then the next one is volume, which is which is the total trading volume. Okay, which is the total trading volume. And then we have daily change percent. Yes, we have that also. So we have daily change. That means basically the percentage change from open to close. Okay, so the percentage change from open to close. So this particular data set contains uh, key price and trading activity metrics, okay, across North America, Europe, and Asia, making it useful for market trend analysis and all, okay. And I've already told you it covers over 10 indices, okay. Um, S&P 500, Nasdaq, Dow Jones, FTSE 100, Nikkei 225, Hang Seng, DAX, CAC 40, SSC Composite, and KSC 100, like that, okay. So yeah, that's all about the data set. Now, guys, you will be wondering why I'm telling about the data set, because I've already always told you that uh, whenever you are just about to perform analysis, so you have a better understanding of your data set. Okay, before going into the programming part or before going into the analysis part, you should have a better understanding of your data set, that from where the data has been collected, what are the columns, what are the meanings of that columns. Okay, what kind of data does that particular column Okay, what is the total means in totality, what is the meaning of that data set, why that data set means, what are the features, what are the things which we can perform on this particular data set. Okay, so these are the things which you must know. Okay, and that's why I just always give you an overview of the data set. Okay, now we'll start by looking at our data set, that how it looks. Okay, so for that again, what we'll do, we'll import pandas as pd, then we'll import numpy as np, and then matplotlib or pyplot as plt. That's it. Let's load it. Now we'll just basically read our file. Okay, so let's do that. Okay, guys, one more important thing. Okay, uh, do let me know about the last live session. Okay, do let me know about the last live session in which I have we have used MongoDB in that session. Okay, and I have used uh, I've told you how to perform the CRUD operations, means we have seen how we can perform the CRUD operations. Okay, so tell me about that particular live session. How many of you were present in that live session? Okay, how many of you have, if not present, then how many of go and seen that particular live? Okay, because that is basically now what is going in the industry. Okay, that was based on that. So how many of you like that particular live session, and then how many of you want me to focus on these kinds of technologies where we can just integrate python with, okay, some of them just means, if you guys want me to use flask fast api, okay, so you guys can just let me know in the chats in what type of technology you want me to take the live. Okay, if you are focusing on data science, then for data science we are regular, we are just doing it after 1 or 2 days. Okay, so we are frequent in my opinion. But if you guys want me to just take live sessions on those kinds of things also, so you can just let me know in the chat. Okay, and tell me that how many of you watched that live session, and how many of you have liked that particular live session. Okay. Okay, so we have loaded the data set, we are checking the shape, okay, and we are seeing some sample of that particular data set, how it's look like. Okay, so shape, as you can see, 18,270 columns are there, oh sorry, rows are there. Okay, and 9 columns are present. Okay, and you can see the whole sample of our data set, that how the data is being stored. So you can see we have date column, we have index column, okay, index name. So this is particularly uh, all the 10 unique indexes which I have mentioned, that will be only there. Okay, then there is the country. Okay, country where that particular index operates. Okay, which I have already mentioned here. Here, as you can see, country where the index, from where the index operates. Okay, then there is open, high, low, close, volume, and daily change percent. Okay, so these are the kinds of columns features we have, okay, in our data set. And how many rows are there? So 18,270. It's a okay. Now, this was a sample view which we have seen. Now let's just do what? Let's print the info about our data set to look out our data types. What are the data types of that particular column is? How many missing values? Okay, let's see whether there are missing values or not. Okay, so as you can see, range index is obviously 18,270, so from 0 to 18,269. Then Total nine columns are there. Okay. Date is in object format. Okay. That should be in date time format, but it is in object. Index name, it is in object. So yeah, obviously index name, country, it is in object, and then rest of the other columns are in float. That's good. Okay. So then we don't need to convert it. We just need to convert the date. Okay. Okay. Now let's just take a view. Now from this, as we can clearly see that 18,217 non-null counts are there, and it is same in all the columns, means in all the columns there is no missing value. Okay, so that is clear that there are no missing values. So now it is unnecessary to go and check for missing values. Okay, but we can check for duplicate values, whether there are duplicate values or not. Okay, so we can give a check for that. So no need to give a check for missing values, because that we can clearly see from here that there are approx no missing, not approx, accurate no missing values present. Okay, from the info. So let's now print the duplicate rows. Okay, and let's see if they are duplicate rows or not. So df dot duplicated dot sum function. Okay, I've written duplicated, not duplicated, it's duplicated. Okay, so this is the duplicated rows. Okay, total count is 0. It means there are no duplicated rows. Okay, now the next thing what we can check, what we can give a check for, that let's see the unique indexes. Okay, so we already know, I've given you an overview that what are the total indexes. Okay, so let's see that. Okay, so unique indices, df index name. Let's see the number of unique values. Okay, so total 10. Okay, and then I'll do what? Just copy it, and I'll just do it for the country. Okay, so in the country column there are 8 totally unique number of unique values, and in the indexes name 10. Okay, okay, so that we have a good idea. Okay, now let's do what? One thing which we have noticed out from the information that uh, this date, okay, this date is particularly in object format, and because we have to perform stock analysis. Okay, and it is based on per day. Okay, from 2020 to from January 2020 to December 2024. Okay, it means we'll need the months, date and years particularly. So for that we need to convert this date, but date column into a date time format. Okay, because as you can see it is in object format, so that's very easy. We have already done it many times, so we'll again do it. Okay, so let's do that. So first of all, let's extract the date column, and pd dot to underscore date time, we are going to use this function. Then we'll put date in this. Okay, and if there would be some values. Okay, let's say if there will be some values which is on string or which is of a different type, so then we are making sure that if you'll convert, so means suppose if you're just directly using the to date time function, so what will happen? Okay, it will convert the date column, but it will give you an error when if there will be in any one of the rows, if there will be any string value. Okay, so then it might raise an error, so we don't want that. Okay, so what we want, then we want that if there would be any string value, so what it should do, it should basically give it a nan. Okay, so if there is a string value, so that string value will be converted into a none value. Okay, so we want that. That's why we are making this errors equals to covers. Okay, so this does basically that. Okay, So this is the date. Now if you want to verify, so we guys can verify it by simply printing. Okay, so you can see date is now uh, in date time format. Okay, it is in date time format. Now guys, rest of the as index name and country, that will be in uh, object format only. Okay, because we have seen country name and index name, they are in object format. Okay, so that's correct. And rest of the other columns are already in integer, means I guess in numeric format, so we don't need to convert it. But what if they're, if they were also in some different data type, then what we should do? Okay, so now we do no need to apply it, but I will just tell you that what you can do if that kind of situation will be there, because it's not necessary, that you guys will also work in particularly this data set. Okay, you guys can work on different kind of data sets. Okay, so in that kind of data set, okay, you can face that type of problem. Okay, so I'll just tell you. Okay, it's very easy what you have to do. Okay, I'll just give you a very quick way. Extract all the columns first. Okay, so extract all the columns which needs to be in numeric format. First of all, do that. So let's say, as I can clearly see from my data set, that name and country and date, so date will be in date time format, that is clear. Index name and country, that will be in object format because they are strings. Okay, and then we will left with rest of the values: open, high, low, close, volume, daily change percent. They must be in numeric format. So we need to convert them. So open, high, low, close, volume, and daily change percent, these are the columns which needs to be converted into numeric format. So I'll just show you the way. First of all, what we need to do, we will extract all the columns, okay, which we feel. So open, high, low, and then there is close, and then there is daily, daily change percent. Okay, then there is daily change percent. So these are the columns which needs to be in numeric format. Now in our data set it's already in a numeric format, so we don't need to worry. But what if you guys working on a data set and they are in different kind of, okay, so then for that purpose what you need to do, you just create a list, you mention all the data sets, okay, means all the columns in that particular list. Okay, then start a loop, then extract each item at a time, means each column at a time, and then just use the function to numeric. Okay, use the function to numeric. Okay, mention the df call, and again errors. If there are some object value present, so then do what? Then just simply, okay, write errors equals to course, which will again do the same thing which we have done in, which I have explained you over here. Okay, so it will also be do the same thing. It will convert the string object values in into a none object. Okay, into a none value. That's it. That's it. That's only what you have to do. Now if there would be, if there would be some values, okay, so for that what you can do, you can just simply write drop. One thing which you can write is first drop duplicates, okay, to remove the duplicates from your data frame. And then one important thing what you can do is df drop na, okay, take a subset where mention the date and the index name. Okay, so if from the date, okay, and then what you can do, one more important thing which you can do is, let's print the set. Okay, you can print the shape of the data frame again to re-verify whether it has since dropped some values or whether some changes have been made or not. So you will see again the data shape is in our case it is same. Okay, in our case it is same. Why? Because obviously our data was already cleaned. Okay, so now again let's just give a look. So everything is same. Let's now go ahead and perform some feature engineering. Okay, so now as you can see what columns we have date, index name, country, open, high, low, close, volume, and daily change percent. Okay, but we will need some extra columns also. Okay, that is called as feature engineering. Okay, so from the columns we have, okay, it might happen that they are, means they are just raw data. Okay, what are these are raw data. Now to bring out more insightful from that, okay, what you can do, let's say there is high and low. So from high and low what we can do, so from high and low we can basically see the daily range, what was the daily range. So we can create a column uh, called as daily range by subtracting the high from the low. Okay, so that can be useful, that can be a very useful column. So these are the things which is come in the feature engineering. Okay, suppose you have a column, okay, and if we have to perform scaling, so that will be also called in that feature engineering part only. Okay, then suppose we have columns called as close and we have column called as open. Okay, so what we can do to check the price range, we can just subtract from close to open. Okay, so what we'll get the total price range. Okay, then we have the date column. So from date column what we can do, so from date column we can extract the year and we can extract the month. Means we have a date time column, so we can extract the year and we can extract the month and we can create separate columns for that. So it will be easy for us only to do what, to just simply see our data set and bring more insightful, generate more insightful from our data set. Okay, that's why this is called as feature engineering. Uh, Hello, Mr. Piyush Kumar. Hello, hello, bro. Yeah. So now the next thing which we'll do here is what I said, the feature engineering. Okay. So here we'll just do what? We'll just create extra columns. Okay, which will be useful for us. Okay. So okay, I can see Sunny Surana has said um I can take live on. I guess he's saying that I can take live on quant and high frequency traders kind of learning. Okay. HFT basically. Uh, okay, that's very good. Okay, I'll next time whenever I try to take a live, so I'll try to take that kind of data set. Okay, so that okay it can be more engaging and more nice. Okay, so yeah, I'll keep in mind. I'll keep it in mind. Okay, Sunny, I'll keep it in mind. So now let's create the columns. So what I have said, let's create one daily range. Okay, so daily range. Okay. So this particular column gives it will give us our daily range. Then next column which we can create is to check the price range. So again, let's create a column. Now let's extract the year and month. So for that, what I'll do, year equals to, okay, we have the date column with us. So from that, we can extract the year by using the attribute dt dot dt dot year, okay. And for the column, what I'll do, just copy it, I'll paste it, I'll I'll change it to month, okay. Then it will everything will be same. Then from dt dot year, I'll change it to month, okay. So that's it, okay. Let's execute this. Okay, so you will see we have now daily range, price range, year, and month, okay. Now what we can do, hmm, let's just, now we all set to go, but before moving forward, let's see a statistical summary, okay, on our numeric columns. So let's do that. And then we'll move forward with whatever operations we have to perform, we'll do that, okay. So let me just first print numeric summary. For that, I hope everyone knows what function we have to use. So the function we have to use is describe for getting the numeric summary. Okay. Okay. So for the date, as you can see, total 18,217. Uh, the start is 2020 January that I have already told you. Okay. And end is 2024 December. Okay. 31st December 2024. Okay. And for open, high, low, and close, if you'll see, the mean is for open, the mean is 20,442. The minimum is 1,000.65, and the max is 39,990. For high, the mean is 20,718, okay, and the max is 40,680. For low, the mean is 20,166, and the minimum is, okay, for low, the minimum is very low, as you can see, 349, okay, and max is 39,985, okay. For close, the mean is 20,442, okay, the minimum is 622, and the max is 40,474, okay. So on an average, we can say that values are around 20K, okay, values are around 20K, but they range a lot from hundreds to 40K, okay. So now one more thing is there. See, this particular data set have different indexes, okay? Have different indexes from different regions and and they are of different ranges. That is also one thing which we need to consider. That as you can see, our data set contains different indices like S&P 500, Nikkei, KSES, and others. Okay, so here you will means getting a summary, the price levels will be different for all of them. So the average which we are seeing here, okay, they are not meaningful for one particular index. Okay, if they would be combined, no, then it can be a meaningful. Okay, so yeah, so now we can move forward, and what we can do, we can just basically we'll start with first of all getting the top indexes and country distribution. Okay, so we'll see the top 10 indexes, okay, and top 10 countries, top countries. Okay, so let's do that. So what we'll do, we'll just basically first of all find the top 10 indexes. Okay, so obviously there are only 10 included, so on that we'll see which one is at the highest. Okay, and then we'll see the country distribution. So let's just first use this. Let's write top 10 indices, TF index name dot value counts dot head. What is the total value count? Okay, so okay, it's totally distributed in proper manner. Okay, so you can see here, SAP, every value means it is properly distributed. 1827, 1827, and for all the rest of the indexes it is 1827. Okay, on the country distribution you will see USA has more, and then rest of the others, UK, Japan, Hong Kong, Germany, France, China, okay, they have 1827. USA has more. Okay, now let's just do what, uh, now let's just perform uh, EDA, exploratory data analysis. Okay, and we'll see the trend over time on the close average. Okay, so we'll see on the close average. So let's write the, so first of all we need to do what, global daily equals to df dot group by, and based on date what we need to do, based on date we need to group by the close. Okay, and we have to do the average of this. Okay, now based on this global daily, now we'll, let me set the fixed size. Okay, and we'll visualize this so that we can get a clear view. Okay, so let's take a 12 by 5 size, global daily index, then global daily values. So let's set the title, Let's make it greed equals to true. Okay, it will be more easy for us to then understand. Let's see the plot. Okay. Okay, so we are getting this kind of plot based on, okay, this gives us a frequency based on year wise 2020, 21, 22, 23, 24. Okay, and you will see over here, okay, uh, the counts. And let me just tell you, x-axis here is the horizontal axis. It is starting from around 2020, okay, and it goes till 2025. Why 2025? Then the y, it goes vertical, which gives us the average close. Okay, this is particularly the average closing price on that date. Okay, it means basically, if suppose, what is average close? If I guys are confused, so let me just tell you. Suppose we have three stocks: stock A, stock B, and stock C. Okay, so suppose stock A close was 10,000, stock B close was 20,000, stock C close was 30,000. So if you have to do the average of all the stocks, so what we'll do, 10k plus 20k plus 30k, and divided with three, so we'll get 20k. Okay, so that will be the average close for that particular day. Okay, so it gives us that. So this gives us on what was the highest, okay, average close for that particular, okay, date. And this line which you can see here, okay, the zigzag lines which you can here observe, this particularly this tells us uh, that the average close price changes every day. Okay, so that particularly means that the blue zigzag lines. Okay, and the observation which we can see here is, you can see this range. Okay, here is very deep, okay, very um dark blue lines, okay, where we can now determine the lines also. What does it mean? This means that the average close price is staying, means it stays mostly between, you can see this range, 15,000, you can say from 15,000 to 25. Okay, from 15k to 25k, it is in that range. Okay, so the average close price is mostly between 15k to 25k. So most of the time, what we can say from this is that most of the time the overall markets average closing price was in this, or okay, in this particular range. Okay, but it's actually very messy and very noisy. Okay, yeah, means we cannot interpret it. Means this means that one thing can we can say from this is that, because we are plotting on daily values. Okay, so the stock prices move up and down every day. So because of that, it creates a sharp spikes. Okay, and this sudden jumps, you can see this highest, okay, approx more than 30k approx. Okay, these are you can say kind of spikes. Okay, these spikes which you can say, which you can see over here. Okay, which is more than 30 k, that is called as the high spike. Okay, and on the below level you can see it is approx, okay, 10 to 12k range. Okay, that is called as the low spike. So it means that there would be someday the market average increased, okay, because of any reason, means big companies maybe performed very well. Because of that, you can see that kind of spike for that particular day, okay. Or in some day you can see there could be crashes also. There could be bad news, or there could be major sell-offs. Okay, so based on that, maybe because of the COVID effect, okay, so you can see that major lows. So So, yeah, so that we can see, say from this particular graph. Okay, so global average close price trend over time. Now, let's now, because we have this, so what we can do, let's just basically see the top 10. means the best and the worst daily change okay, according to the days. Okay, so let's see those values. So we'll see best 10 days, okay, in these following years, and worst 10 days in these following years, okay, based on our data set. So this is also the part of EDA only. Now whatever we are doing, we will do inside EDA only. Okay, so if I'll forgot to tell you, so then we are doing that only. Okay, so now what we'll do, we'll see the best and the worst days. Okay, based on, so let me create best days. So df dot sort values daily. uh what was the column name? I have to go and check. Daily change percent. Okay, and then I'll do what? Sort values, and I want the best. So what I'll do, I'll make the ascending equals to false. So I'll get the highest ones, okay? And I'll do head 10. And I'll just do what? I'll just copy the same thing and I'll paste it over here. I'll just make few changes. I'll change the best to worst days, okay, and then based on the same daily change percent, and I'll make the ascending equals to true. Okay, so I'll get the lowest values. Okay, and then and now I'll try to print them. Okay, so best 10 days, and I don't want everything. Okay, so what are the columns which I want to show you is I want the date. Okay, then I want the index name. Okay, that is important. Okay, then I want the country, and then what I want the daily change percent. Okay, based on what we are doing. So I'll just copy it, I'll paste it over here. Why to waste time in writing if I can just simply copy paste it? Okay, so you guys can also do that. And I'll just make few changes from worst 10 days, and I'll change the data frame to worst now, worst days, and that's it. Okay, let's print this. So best 10 days, you can see, to make it look more clear, more readable. Okay, I'll just put one more print here so that there should be a gap between. So best 10 days, guys, you can just see uh, on 2022. Okay, 7 March 2022. Okay, KSC 100. Okay, have the daily change percent approx 45.69. Then Nasdaq Composite USA has 45.44. Worst is again 2024 5 KSE 100. Okay, daily change rate is minus 44.32. Then Nasdaq Composite USA has minus 42.72. So yeah, and then rest of the values is with you. You can just check, okay, whatever you want. Okay, now let's just visualize it. Okay, let's just do what? Let's just visualize it and then understand. Okay, so now we'll visualize the daily change percent. Okay, the daily change percent distribution. Okay, which will which will give us the market volatility. Okay, so let's just do that. So what we'll do now? So basically, okay, we'll visualize daily change distribution. Okay, so let's just quickly do that. So distribution of daily change percent. Okay, let me set the X label and Y label. So X label is the frequency, PLT dot. Let's just make grade true, PLT dot show. Okay, okay. Let me just zoom out a little bit. Okay, so that the whole graph should be okay. Yeah. So yeah, distribution of daily change percent, guys. Okay, so this is the graph. Okay, based on our data set. Okay, this is what we got. Now, if you'll notice, um, on most days, so this is the x-axis and this is the y-axis, which giving us the frequency. X-axis is basically the daily change percent. Okay, so the negative values here, it means the price, as you can see, minus 40, minus 20. This means what? This means that um, um, price went down. Okay, and then the positive values which you can see for 20 at 40, that is means price went up. Okay, and 0, approx 0%. Okay, it means almost no change. Okay, y frequency, obviously, y axis gives you the frequency, means basically shows how many days fell in that particular percentage range. Okay, so in simple, if I'll tell you, the taller bar you can see, okay, the taller bar here means that it happened more times. Okay, so this is how you read this kind of particular plot. Okay, so this is a histogram. So this is how you read a histoplot. Okay, now let's see what our plot is telling. Okay, so from the look, we can say that the highest bar is on 0. Okay, so is the most of the bars are packed around 0% only, if you'll see. Okay, and then it in this kind of tails, you can see on the tails it is very minimal, very tiny bars. Okay, very tiny bars, but the highest ones with more than 5,000, approx 6,000 frequency is at around 0 only. Okay, so this means what? This means that there would be most of the days the stock prices change very little, like 1%, 0%, okay, -1%, okay, etc., 2%, -2%, okay, this kinds of thing. So whenever you perform a stock analysis, no, so when you see this kind of thing, okay, so that is a normal behavior. Okay, means the stock goes up and down. Means there are very few stocks who go very fast. Okay, approx with a high percent daily change. Okay, so that is very rare. This is the normal. It goes with +1, -1. It goes like day every day. Okay, so that is a continuous process. This is what happens. Okay, so I can see and I can say from this that the shape is almost like a bell, okay, almost, okay, it seems like that. So it is centered around zero. If you'll notice, you can clearly see it also. It is centered around zero, okay, and it is spreads towards the left and the right both, okay. It means simply daily changes are mostly very small, okay, because you can see the whole most of the frequencies, most of the tallest bars is around zero only. Maybe -1, -2, -3, -4, okay, and -5, minus +5 till +5 range, okay, +10, few, very few changes, okay, not a very big change, okay. And you can see there are bars, okay, if I'll zoom little bit, you will see around -40, okay, which will be the very low, and approx +40 also. There are bars, but they are very tiny, very, because I have to zoom that much, okay, as you can see. So they are very tiny. It means that what? Means the big changes, whether the lowest or the highest, okay, so the big changes happens very rarely, okay, very rarely. And the long tail is approx -45 to +45 range, okay, so these are very extreme sides, okay. And these tiny bars which you can see approx -45 and +45 is called as tails, okay. So with this we can say, by looking out the tails, we can say that there would be some days that had very huge crash or very huge jump, okay. But those days are very rare, okay, because the bars are tiny there, okay. So yeah, this is what we can bring out from this particular plot, okay. Now let's move to the next one, where we'll see the highest volatility indexes, okay, by the standard deviation, okay, and we'll understand. Based on that, we'll look out our data. So uh let's see the highest. Okay, let me just zoom it, otherwise uh you guys will not be able to see, okay. So what we'll do, okay, by standard deviation of daily change percent, okay, of daily change percent, based on that we'll see the volatility index. So first of all, let's just create df dot group by based on index name with daily change percent. Okay, we'll do the standard deviation, okay, and then we'll sort the values. And because we want the top 10 most valuable indexes, so what we'll do, we'll make the ascending equals to false. That's it. Then what we'll do, we'll just print all the values, okay. Before printing, we'll first print that top 10 most volatile indexes, okay. Print index, not like this, not inside. dot head. We want top 10, so top 10. Okay, which one daily change percent? Oh, R is missing, so I'll put R. Okay, so we'll get this. So you can see the daily change percent. Okay, for FTSE 100 typically varies about 4.84%. Okay, 839, it means 84%. Okay, so around its average. So FTSE here, FTSE 100 has bigger daily swings, meaning it is the most volatile index in your data set. Okay, so this is basically how much it fluctuates. Okay, so what we are doing in this particular line, we are extracting the standard deviation. Okay, it means that if the standard deviation is high, it means that the daily returns moves a lot. Okay, moves more ups and downs. It means they are very risky, more volatile. So what is volatile? Volatile means there are very ups and downs, so it's a risky. Okay, and if the standard deviation is low, it means the daily returns are more stable, which means less volatile. Okay, so you can see Dow Jones is 4.10, approx all are in the same 4 range. Okay, but Dow Jones in comparison to the FTSE 100 is more stable, we can say that. Okay, so okay, now let's just go forward, and now let's just do the volume analysis. Okay, it means now we'll perform volume analysis. What does it mean? It means we'll see the most traded indexes. Okay, so top volume, again we have to do group by based on top 10 indexes by average volume. Okay, because we are doing the mean. Now based on that, let's just quickly plot it also. Okay, so let's just plot two at the same time. So on the top volume dot plot, what kind of plot? Let's use a bar plot. Let's set the size. Okay, let's give the title to. Okay, so I'll keep the title same. PLT dot show. Okay, so this is the value. Okay, let me just print this too, so that we should get the exact number also. So Hang Seng, okay. Hang Seng is the indexes, okay, which has the highest volume, highest average volume, okay. So it's around Hang Seng has around 20 uh, it's power 7, okay. 10 to the power 7, it means approx 26 million average, okay. 26 million, okay, average volume is for the Hang Seng, okay. So 25.99 around 26 20, let's be accurate, 25.99 million, okay, for this. For DAX, uh for DAX index, it is one second. Yeah, sorry for that. So for DAX, it is 25 point prox 92 million. Okay. Then for Dow Jones, it is 25.85 million, and then for FTSE 100, it is 25.29 millions. Okay. So we can say here that Hang Seng has the highest average trading volume among all these. Okay, among all the indexes present in our data set. One more thing, if you'll notice that all the averages are very close to each other, okay, approx 24.2 million to 26 millions, okay, so they are very close enough, okay. And if and one more thing, they are very close, but because they are very less in number, so that's why we are not seeing a variety of ranges here. Okay, but if you'll see a real stock market, okay, so then the volume differences between the indexes means they are very often much larger. Okay, often much bigger, larger. Okay, so that is the thing. Okay, and let's look around the plot. So if you look around the plot, you will see that the plot are approx in declining manner, okay, obviously because we have plotted for uh, the top 10 indexes by average volume, okay, they are all above, okay, 2 range, 2.5 range, okay, they are all above 2.5 range, okay, so they are very close enough, okay, so bar also gives us, with visualization also we can say that they are very close enough to each other. So this is also one kind, okay. Okay, now just quickly see the correlation, okay, correlation between the indexes, between the columns, that how they are connected with each other. Let's see that, okay. So now the next thing which we'll see is the correlation heat map, okay, based on the numerical columns. So first of all, let's just extract the values. So open and high, then there is low, close, volume, and daily change percent. And now we have added few more columns, which was one was daily range, and there was one more that was price range, okay. So price range dot core. So this function used gives us the correlation, okay, between the numerical values. Then we'll plot it using heat map. So for that, again, we need to set the figure size. If we'll not set the figure size, then also it's fine. It's take by default size, but I want to set it. So that's why I'm using this. We'll set the aspect ratio to auto, then plt dot color bar, plt dot xsticks, tscks, okay. In xsticks, there will be the range of the length of the core dot columns, then core dot columns, and a rotation. Let's give the rotation as 45, and plt dot whiteix. We don't need the rotation, and rest of the things would be same. Then okay, plt dot show. Okay, and before that, if you want, you can set the title too. Let me just quickly set it. Okay, again, I need to zoom out a little bit. So first of all, guys, those who are new to this kind of plot, so let me just tell you what is this correlation means. Okay, so correlation values range from -1 to +1. First of all, okay, understand that. If the value is close to +1 or if the value is +1, so what does it mean? So if the value is +1, then it means that it is a perfect positive relation. Okay, perfect positive relation means that suppose if it gives us a relation between column A and column B, so if A increases, so B also increases. Okay, so that is perfect positive relation. And when does it happen, perfect positive relation? When two columns are related with each other and generating a value +1, so then we can say that it is perfect positive correlated. Okay, so it means that if suppose um, if column A is increasing, so column B will also increase. Then there is zero. Zero means, or values close to zero means no relation. Okay, then there is -1. -1 means -1 also has a relation. -1 means perfect negative relation. Okay, now it does the opposite. Let's say if you have two columns, column A and column B, so if we have a perfect negative relation, so it means if column A increases, so B will decrease. Okay, so that is perfect negative relation. So you can see from 0 to 1, it's all mostly positive correlation is trend. Why? Because values open, high, low, close, they are and one more important thing, as you can see, open, high, low, close, and again open, high, low, close on the x-axis and on the y-axis, they are totally in yellow. Why? Yellow means one, positive. They are perfect positively correlated because they are correlated with each, means with themselves only, with itself, the column. So there is one more thing, that the column with itself, means open with open, is always positively correlated. Perfect positive correlation is there. Okay, so column with itself is always +1. Okay, so that's why you will see in the diagonal open for high, for low, for close, for volume, okay, for daily percent, for daily range, for daily price range, for all these you will see +1. They are perfect. Okay, so that is there. Here you will, first thing which we have noticed is this thing, open, high, close are highly correlated. Okay, because they are correlated with each other. Okay, because of that the column itself is correlated. But open with high also means open with high, you will see means open with open is yellow color, but open with high 2 is in highly, means it is perfect positive correlated. It means if open increases, so high also gets increase. Okay, so it has a total impact. So we can say if open is high, so close is also, as you can see, in comparison in for the high, you will see open is high, so the close is also high. Okay, it is also perfectly positive correlated. So this particular thing means if open is high, close is also usually high too. If close is high, so high is also high. Okay. So these values move together. Open, high, close. Okay. So they mostly moves together. Okay. And this is very normal in stock data analysis. This is normal. This kind of things you can see. Okay. You will get to see these kinds of things. So they are this is normal. This is not something which is very interesting or very rare. No, it is common. These kinds of things we see. Okay. Now one more thing. Uh, in points of in consideration of machine learning. Okay, if you are taking this data set after EDA, if you are taking forward for machine learning, okay, so then these four features can be redundant. Okay, they can be means they are too similar. Okay, so using all of them sometimes can cause collinearity. Okay, so you can use either one of them. Okay, which has the highest accuracy. Based on that you can use it, so that your model will be trained, okay, not on same data. Okay, so the model performance will increase, the accuracy will increase. Okay, then one more thing which we can notice here is uh, volume has very weak relations with price. Okay, with prices, the volume, the row column looks mostly dark purple. Okay, very dark purple type. Okay, so this means particularly does not uh, the volume um, does not strongly move with price levels. So it means the volume means volume may spike even if price does not move much. So volume is more related to market activity, not directly with the price value. This is one thing which you can notice. Uh, Then one more thing which you can notice here is the daily change percent and the price range. Okay, they are strongly correlated because they are, you can see they are in green color, approx 0.6 to 0.8. Okay, so they are close to plus one. This means what? That you can this means that they are close to one, means they are highly positively related. Okay, so it means that daily change percent and price changes, they are related to each other. Okay, and positively related. So that makes a perfect sense, uh, that we can say that price change is what, close minus open, and daily change percent is what, um, if you have to calculate the daily change percent, how you are going to calculate it. Okay, so I'll just show you why they are highly correlated, that I'm trying to tell you. Okay, and these are the things which we have to understand. See, price change, how we have calculated the price change. So we have calculated the price change close minus open. And how to calculate the daily change? So the daily change percent is something like this: close minus open, okay, divided with open, okay, into 100. So this is how the daily change percent is calculated. So both the measures the same thing. One in rupees dollars absolute form, and one is percent form. So that's why the correlation is high here. Okay. The fourth thing which we should notice is the daily range. Okay, the daily range has low correlation with most of the features. Okay, if you'll notice, with most of the features it is uh, It means was the daily, what was daily range? High minus low. So it basically measures intraday volatility, okay, not the directions. It means that if there is a high daily range, means the big movements up and down, okay, but there is not, means it means but still close near the open, okay. So that's why this daily range does not strongly correlate with the price change or the close, okay. So can basically with this particular plot we can say that, okay, that the open high close, they are strongly correlated, okay, because they carry similar information. Second thing, okay, let me just write each and everything. First, what we calculated, not calculated, what are the conclusion from this heat map? First is that open, high, low, close are strongly correlated, okay. So they, because they carry similar information. Then second, volume has weak correlation with prices, okay, because volume behaves differently because of that. It's not dependent on the price. Then we can, the third thing, price change percent and the price change are highly correlated. How we can say that? Because both represent price movement that we have already seen in the upper cell, okay. Then the next thing is uh daily range. The daily range represents okay, volatility. It represents volatility, okay, that is mostly independent from direction, okay. And one machine learning tip I can tell you, if you target the close price predictions, so keep open volume daily range, okay, maybe the price range also. If you target close price prediction, then you can keep open volume and daily range and price range. But uh, if you are just not targeting that, so then you can avoid using open high low close, okay, because they together they are too similar. So because of that, you can ignore one of means these things, okay, if you are not calculating the close price prediction. Then now let's go forward. Now let's just do what, let's, because it was from 2020 January to 2024, it means it has the COVID era also. So let's just do what, let's just analyze the COVID era analysis, okay, before, during, and after, okay. Let's just do that, and let's just understand based on that. So for that, what we'll need, I'll just do what, I'll just create a function. So based on that function, what I'll do, based on that function, I'll separate, um, I'll give a date range, and based on that rate range, okay, we'll separate the COVID period with after COVID, before COVID, and during COVID, okay. So df dot COVID, okay, period, date, and I'll give a condition that if date is less than PD dot time stamp 20 2020 dash 03 dash 01. Okay. So if it is like that, it means it is before. So return here before before COVID. If the date ranges between uh, uh, date less than PD dot timestamp 2022 01 01. If it is in that range, it means it is during the COVID period, okay? Because COVID was till 2022 January, okay? Means 2021 was fully covered. So we'll put here during COVID, and in the else now simply we can say that return after COVID, okay? Then what we'll do, df will create a new column called as COVID period, where we'll use the date, and on the date we'll apply the function, and then let's just print the COVID stats. So df dot group by, okay, so based on the COVID, we'll see the daily change percent, okay? And what are the things which we want? So aggregation of mean, standard deviation, minimum and max, okay? So here, what are the things which we want? We want the mean, standard deviation, mean value, and max. And then this, okay, all set, code seems correct. Let's just print volatility stats, okay? COVID stats. Okay, let's execute this. Okay, so now this is what we are getting. So you can see the average daily change. If the value was positive, it means that market went up slightly on average. Negative means market went down slightly on average. Okay, standard deviation here means um higher standard deviation means more ups and downs, okay, means it is more volatile. Lower standard deviation means that it is more stable. Minimum means that worst single day percentage drop during that day. Maximum means best single day percentage rise during that day. So after COVID, you will see the mean is on average minus 0.0338. So market was almost flat but slightly negative. Standard deviation is 4.4909. Okay, it means volatility is around 4.49% per day. Minimum was 44.32%, means worst day was a huge drop, about minus 44%. Max is approx 45.69%, means best day was a huge rise, plus 45%. Okay, so this period has the lowest volatility among the three, but if you'll see, still very high. Okay. Now, before COVID, if you'll notice, before COVID, the mean was minus 0.2022. So, on average, the markets fell, okay, slightly each day, okay, more negative than others. Standard deviation is approx 4.7999. It means the highest volatility you can see it is in before COVID, okay, of all the three periods. Okay, so it was most unstable before COVID. Minimum is minus 40.53%, means worst day was minus 40.5%. Max was 39.37%, so best day was having 39.4%. Okay, so according to this particular data set, before COVID is the most volatile, which is a bit surprising. Okay, it should be during COVID ideally, but because with this data set, okay, now this is the synthetic data set, okay, not a real data set. So based on this data set, this is the result which we are getting. Okay, now during COVID, if you'll see, during COVID, the mean is 0.0897. It means uh, the market went slightly up per day. The standard deviation is 4.5788, so volatility is high, but less than before COVID. Okay, minimum is minus 42.15%, so worst daily crash was for minus 42%, and max is 45.20. It means the jump was 45. Okay, so during COVID had massive extreme swings, very big drops and rises also. So based on volatility, means the standard deviation comparison, we can say that before COVID, okay, 4.80%. So before COVID is greater than during COVID, and that is greater than after COVID. Okay. So markets were most unstable before COVID, still highly unstable during COVID, and slightly more stable after COVID. Okay. So that is what we can say. Okay, from this particular analysis. If you want, you can just plot it also, okay, using any bar plot. Okay, any bar plot you can use it, and you can just plot it also. That is also what you can do. Okay, now if you want to see the best performing indexes, okay, so the best performing indexes, which was the best performing indexes, so that also you can just see by grouping out index name and daily change percentage. Okay, you can do the average and you can sort the values. Okay, so I'll not do that because that we have seen the similar thing in our in the starting of the video only. So now what I'll do, suppose if you have multiple companies and stocks, okay, so based on date, what we'll do, we'll take the average of the close, okay, and then we'll try to create the COVID periods before COVID and during COVID and after COVID, okay, with that particular daily average. Then we'll do the mean, okay. We'll try to remove the noise and show the trend clearly, and then we'll try to figure it, okay. We'll figure multiple plots separating COVID period and the normal after COVID period, okay. And then in last we'll see a total comparison during COVID and after COVID to understand how does it works and what was the differences, to analyze the differences during COVID and after COVID. Okay, so there are few things left. Let's just quickly do that. Okay, so first of all, we need to calculate the daily average. Okay, based on the close, based on the average close. So let's see that. So daily. Okay. Now what we'll do, we'll create the COVID periods. Okay. So let's just quickly do that. So now we have seen the COVID periods, but we have not created it. So let's create it now. So, so before COVID, let's give the range. So daily average, from the daily average uh, date less than this timestamp 2020 minus 01 dash 01. Okay. So this is before COVID. Then during COVID, it will be uh, greater than equal to 2021 11. And here I have to do one thing. I have to make it inside the braces like this. Okay. And then you have to give and I have to give one more range, that is daily average, okay, with the date with this particular range should be less than uh 2020 2021 12 31st. Okay, so within this range during COVID, and after this range after COVID. Okay, so after COVID is daily average. Okay, that's it. Let me execute this, and yeah, good to go. Now we'll do what? We'll just make it very, uh, we'll remove the noise and shows the trend clearly. So for that, basically, uh, daily average, will create a new rolling 30. Okay, so we'll create a rolling mean where we'll extract the daily average based on average close, then dot uh, rolling window equals to 30 dot mean. Okay, so this will remove the noise and it will show. Let's just now, uh, so let's just plot the first plot that will be based on. So in this particular plot, we'll try to separate the before COVID, during COVID, and after COVID. Okay, so let's do that. So 14 is to 6, 50 dot plot based on the date. Average close Same thing. We'll do it for um during COVID and after COVID. Okay, so I'll just need to change very few things. During COVID, I'll just copy it, I'll paste it over here and paste it over here during COVID. And then I have to just do the same thing for after COVID. Copy it, I'll paste it over here. Okay, guys, just give me a minute, okay? Someone at the door. So, yeah, just give me a moment. I'll be right back. Yeah, I'm back. I hope I'm audible, okay? So, please, guys, if I'm not audible, please let me know in the chat, okay? So, yeah, so, okay, so we have extracted all the three things. Now, what we'll do, yeah, now let's set the title. So, average close trend comparison. Let's tell the X label, date, let's tell the Y label, then, okay, let's give the legends also so that um, it should be more meaningful, understandable, that what ranges shows what value, okay? And at the end, plt dot show. That's it. Let's see the graph. Okay, so average close trend comparison before, during, and after COVID. Before COVID is with blue color, little bit here. During COVID is with the orange color, and after COVID is with the green color. Okay. So this clearly shows us that this was the value ranges. Okay. And during COVID, there was more uh, fluctuations. Okay. um, it was not that much stable. Okay, means the spikes, as you can see, there are very big low spikes and very big high spikes in comparison to after COVID. Okay, as you can see the ranges, so there are no any high spikes after COVID. Okay, it is under 30K, but during COVID there was many, okay, many days where was the spike was above 30K, approx 32, 33, and one was approx 35, 40. Okay, so this is what we can see, okay, before COVID and during COVID. Now we'll do what? Now from this we are getting some, means some value, some insights that yeah, during COVID it was not that much stable. It means it was more volatile in comparison to after COVID period. Okay, so this will be more clear with the box plot. Okay, so when we'll use the plot, so for comparison purpose, so it will give us more insightful. Okay, so when we'll use box plot for both the periods, so let's do that. Let's do that, and yeah, and let's analyze that what is happening. Okay, so period, period equals to after COVID, and daily average location with date less than, again we have to set it 2020 dash 01 dash 01 is, we can say that as before COVID. Daily average, again, date greater than equals to, okay, and I have to put it in inside the braces, okay. So here we have to give the range again, 2020 dash 01 dash 01. That's it. So this range and between this range where daily average, uh again I have to start it with the braces, where daily average date is less than equals to, so greater than 2020, less than equals to 2021 dash 12th month 31st date, okay. Period. So this is during COVID. This is during COVID. So we have before COVID, we have during COVID, and we have after COVID. So now what we can do, now we can start with plotting the box plots. So figure, fixed size, box plot, column equals to average close by, do it based on period. Then let's keep a subtitle, leave it blank. Let's just set the X label. That's it. Let's have during COVID and after COVID. So this is the plot, okay. Um, Let me just explain you this blocks plot, okay. Then we'll move forward. So you can see the green line, okay. You can see this green line, okay. This green line over here, okay. Now it is visible. So you can see this green line in the middle of that box, okay. That is inside the box. That is basically the median, okay. Median means the middle, the average close value. 50% values are below it and 50% values are above it, okay. So that is the average median value, okay, which is close, okay, close value to average, that is close value to the average. uh, in our plot you can see this, after COVID it is around 20k, okay, and during COVID the median was slightly higher in comparison to after COVID, means it was approx 2500, 21, means 20.5k to 21k approx that, okay. You can see it is slightly higher. So means this means that during COVID the means the typical middle average close price was slightly higher, okay. uh, then this box, what is this box? This box is uh, the middle 50% of this IQR, okay. So it is IQR is the differences between the third quartile and the first quartile to eliminate the outliers. Okay, so it is the IQR is basically equals to third quartile Q3 minus Q1, third quartile minus the first quartile. Okay, so the box shows values between the first quartile and the third quartile. Okay, so this thing is the first quartile 25%. This is the third quartile 75%. Okay, and the range is called as the IQR. So here we can clearly see both periods have almost similar box heights. Okay, it means that um, most prices were spread similarly in both the periods during COVID and after COVID. Okay, based on this data set. Okay, remember these things. Okay, then this whiskers you can see over here, the range. This determines us the lowest and the highest values excluding the outliers. Okay, so outliers as excluded, as you can see, outliers are outside that. Okay, so here you can see that after COVID, the whiskers are around from 11K to 30K. Okay, but during COVID, the whiskers were from 10.5K to 31K. Okay, so it is again. So during COVID, it has slightly higher top range. Okay, it means it has more high values days. Okay, so during COVID, we have more high value days. Okay, now you will see uh, the outliers. Okay, so this circular thing which you can see in after COVID below, and in the high ranges you can see during the COVID. Okay, this is basically the outliers. They are called as the outliers. Okay, outliers means the unusual days that are very high or very low compared to the normal days according to our data set. So in this plot you can see after COVID there is one low outlier. Okay, near 9K. Okay, around 9K. And during COVID you will see uh, means during COVID there were many high outliers around 31K to 33K. Okay, so this value you can see. So this means that during COVID had more extreme high spikes. Okay, clearly we can see means more unusual high price days, while after COVID had fewer such extreme peaks. Okay, so what we can say from this, the if we'll say the whole comparison, okay, based on that we can see that overall typical average closing price is nearly the same. Means in both the median price is around 20K. During COVID, there has more outliers on higher side, on the high side. Okay, so during COVID, there were more sudden price jumps. Okay, which you can see here. Okay, let me just make the yeah, which we can see here. And during COVID, it seems slightly more volatile. It means more extreme points, slightly larger spread also. Okay, so that is uh, the comparison between during COVID and after COVID. Okay, based on this particular data set. Okay, so yeah, this is all what we're gonna see, what we saw in our this live session particularly. Okay, and yeah, I hope you have understood how the if you have a stock data set with you, how you can perform a stock analysis. Okay. Now the future things in this is that you can train your model, you can come up with different models and you can train them and you can uh, forecast, you can start prediction. Okay. So that kind of thing you can do. Now predictions here can be multiple. Predictions here could be for particular indexes. So you can analyze one index and based on that you can do the index predictions for that particular index, or for particular one day you can do the predictions, or for after 1 month what could be the value, based on that you can do the predictions. So it's upon you what you want to do. Okay, so yeah, this is how you can continue. Okay, so for this particular live session we'll keep this much only. Okay, now this is not the end, guys. We are left with our quiz session, so we'll continue with our quiz session. Earlier we were doing in the starting of our class, now we'll do it at the end of the class. Okay, because we have covered all of the things now. uh, So let's now see few questions, okay, few quiz question based on yes or no. Okay. So let's start with our first question. So the first question for this is on your screen. Let me just make it more zoom. Okay, yeah. So the first question, does the data set contain multiple stock market indexes from different countries? Okay. Now these whole questions which I'll be putting here, okay, on the screen is based on today's class only, okay? So then it will be easy for you guys to reply based on that, because whatever we have seen, you have to reply on based on that only. So the question is on your screen. You can reply by saying yes or no. Okay, so I can see one yes in the chat. Okay, so I can see one yes. So let's go with yes. So yes is the right answer. Okay. So guys, if you guys have attended the live session, okay, and if you know the answer, you can just reply it. Okay. It's very easy. Now let's move to the next question that is on your screen. That is the date column required to be converted into date time format for time series analysis? Yes or no? So basically, in our data set, whether we needed to convert the date column into a date time format, or it was already in date time format. Yes or no? Okay, I can see one yes in the chat. So with that, yes is the right answer. Okay. So for question number two, yes is the right answer. So we'll go with yes. Now let's move to the next question. That is question number three on your screen. Okay. Uh, hi. Not hi. Yeah. So the next question is, can daily change percent be used to measure daily market volatility? Yes or no? Means for daily market standard deviation to check the highs and lows, can we use the column daily change percentage for that? Yes or no? Yeah, rightly said. Yes, yes, that can be we can say by checking daily change percentage, so we can use daily change percentage to measure the daily market volatility. Okay, so yeah, let's see the next question that is on your screen. uh, is volume always a reliable indicator of price going up in the data set? Okay, this is a very good question. Okay, so those who have seen it very deeply, they can only reply this. Okay, they can only give the correct answer. Okay, because this was one of the things which I have said in the live. Okay, so is volume always a reliable indicator of price going up in the data set? Yes or no? Okay. Well, no. Yeah. So I can see one person is said no, and that is totally correct. Okay. So volume cannot decide the price here. Okay, in this particular data sets. Okay. So volume can decide the direction, but not okay the price. So price is the volume is not the reliable indicator for the price. So the answer is no. Yes, it is correct. Yeah. By this we have came to our last question for this particular live session that is on your screen. That question is, can we compare market behavior before, during, and after COVID using that data set? Is it possible? Okay, so that we have done it now only. So, guys, let's give the answer. Again, I repeat the question. Can we compare market behavior before, during, and after COVID using this data set? Yes or no? Okay, I can see one yes in the chat. Okay, so we'll go with yes. And yes is the right answer for question number 5. Okay. Now, guys, and one more important thing. If you want this class file, okay, so I'll put it, I'll give you a link. If you want the data set for that also, I'll give you the link, okay, and you have to just go and download it from there, okay, you can do that. Um, so, all right, everyone, uh, that's a wrap for today. In this live session, we worked with a real global stock market data set, understood the columns, cleaned the data properly, did feature engineering, perform EDA with visualization, and even compared market behavior before, during, and after the COVID period. So, thank you so much for joining and staying till the end. I really appreciate your time. Take care, keep practicing, keep learning Python, and keep growing your skills in data science. See you in the next session. Bye bye.